Good day everybody, my name is Nora Lizarti. Today I will present my social network final project, and this project related to NFL Big Data Bowl 2022 challenge. I will start my presentation. So first of all, it's about background. As we know, NFL is a popular sport in America, and special team is one of strategy team in NFL. Many people might underestimate the impact of special teams. However, special team plays can mean the difference between winning and losing. Actually, special team performance alone is not going to win a football game, but it can make a significant impact for the outcome, with over a touchdown difference between the best and worst punt units. For example, to get a good field position to start its offensive drive, or even they can achieve touchdown from the interception ball. This change actually can occur in kickoff and punt situation. Because of the importance of the special team play type, especially kickoff and punt performance, and also player performance in each position, our goal is to predict the special team play type outcome, scoring or not scoring, and recommend partner for kicker and returner to improve the team winning strategy. So let's jump to the main objective of this project. So our goal first is to predict a successful attempt based on several features. Of course, I have done the pre-processing stage, where I carried data mining process. There are also 3 new features that I added, and this feature helped me in boosting the performance of the algorithm in making prediction. The second objective is related to social network analysis. I will look for the relationship between players, or we can say the internal link between nodes, where node is the entities, for example, is kicker, returner, and tackler, and the edge will be the relation between them. Here I will use college as connecting feature between each player. And in the end, the result will be useful for best partnership recommendation between players. So from Kaggle data, the most interesting statistic is the special team play type, where we can see that kickoff and punt are the play types that contribute the biggest score in the special team. Therefore, an idea arose to see the relationship between kicker and returner. The point is, in the game, kicker does not work alone in generating score. Support from other players will affect the outcome of the match. Likewise, the returner is not alone in trying to win the ball position in defense team. After conducting an in-depth analysis of the Kaggle dataset, I see there are 3 types of players who have influence on the kicker performance, such as gunner, tackler, and assist tackler. Gunner is a player on kickoff and punts who specialize in running down the sideline very quickly in attempt to tackle the kick or punt returner. And the tackler are mostly in charge of outside protection for kicker offensive team. And assist tackler is a player that head tackler in case mistackle the defensive team. Overall, the function of this player is protect the kicker. While on the defensive team side, there are special team safeties, punt rusher, and vice, which also have no less important role for the returner success in defending and even generating winning scores. A punt rusher in football is a player tasked with getting past the opposition and blocking a punt attempt before the kick can be made successfully. The safeties are the last line of defense. They are expected to be reliable tacklers to help returner to secure the ball position, and vice primary goal is to stalemate a gunner and keep him from making a tackle. All of these player positions contribute to successful attempt in kicker and returner performance. To achieve my first objective, I used 2 different approaches for prediction model. In first part, we will do modeling prediction using machine learning and deep learning approach. We use machine learning methods such as k-nearest neighbor, random forest, superfactor classifier, stochastic gradient descent, decision tree, superfactor machine, and in deep learning algorithms such as multi-layer perceptron and convolutional neural network. It aims to compare the method used to determine the toughness of the algorithm being tested. For dependent variables or target is even score, where I generate in pre-processing stage, and for feature I will use 11 different features, and we can see that kick accuracy, return accuracy, and player college are new features that I got from pre-processing datasets. And in second part, we also generate model-based graph approach using GNN. The GNN can be built up by a sequence of GCN layer and nonlinearities such as ReLU. We use this concept to build model prediction in Kaggle datasets. First, we build graph to represent kicker and returner as not and even score relation as edge of these graphs, and we run it using GNN algorithm. In the end, we will compare which prediction model perform better in our dataset. As for our final project results, we do prediction with 6 machine learning and 2 deep learning algorithms. We also use GNN to do prediction. The results of prediction modeling are very satisfying. The average accuracy is above 90%, and we can observe from the modeling experiments that machine learning models have results that are not much different from deep learning and graph-based model. We can also see that GNN achieved like 94% of accuracy. This result shows that deep learning model perform better in terms of prediction tasks, especially in NFL American football datasets provided by Kaggle. And for social network related results, I use a directed graph to describe the relationship between kicker and returners to players who support their performance. For example, this is a graph that depicts the relationship between kicker and gunner with even score as the attribute. And this graph visualizes the relationship between kicker and tackler. In this example, we see a self-loop incident where the kicker also acts as a tackler. And this is the graph that visualizes the relationship between kicker and assist tackler. We also find a self-loop on this graph. Then this is a graph that visualizes the player-kicker relationship based on the player's university. We can see that each player cluster into similar university. Blue node represent the kicker node and green node represent the super system such as gunners, tackler, and assist tackler. I also analyze the relationship between the returner and the support system. For example, this graph is visualize the relationship between returner and punt rusher, and this graph is visualize the relation between returner and special team safeties, and this graph is visualize the relation between returner and vice. And each graph, we do not see a self loop where in the defense position, in fact, each player will stay in the same position in the formation to defend their area or achieve ball position. And this is a graph that represents the relation between returners based on the player university. So the second objective is recommender system. We're using the concept of bipartite graph and network package to build recommender system in Kaggle datasets. Bipartite graph is the fundamental data structure in the collaborative filtering method, and it's widely utilized in recommendation systems such as Netflix and Amazon. Inspiring by that idea, we want to build simple recommendation system that can recommend player partnership. For example, between kicker and their support players such as gunner, tackler, and assist tackler, or between returner and their support players such as punt rusher, safety, and vice. As we can see, our system recommends kicker and returner support system based on their neighborship similarity. For example, kicker ID 45603 has similarity with kicker ID 44966 in case of kicker and tackler, and assist tackler relationship, but doesn't have recommendation for gunner. We also evaluate the performance of our recommender system using the AOC ROC evaluation matrix. As we can observe from figure, our system only achieved like 49%. This happened because using even score and college name as feature is not enough to recommend players in the American football dataset. Adding more feature in future may be boosting the performance of the recommend system. And also, there was no statistical result that shows that player college variables have significant relation with players' performance. So the conclusion of our final project is in this project we made successful attempt model prediction using 6 machine learning algorithm and 2 deep learning algorithm, also 1 graph-based algorithm. As a result, there is no significant difference in the prediction result of all algorithms. The average accuracy obtained is above 90%. However, we can see that for the Kaggle dataset, the deep learning approach is more suitable than the graph-based approach. And second, we built a recommender system using the collaborative filtering method with the result 49% AUC This happened because even score and college name not enough as a feature for recommending players. Adding more feature might be boosting the performance of recommending system. Okay, I think that's all for my final project presentations. Thank you very much.